Okay, in section 8.2 we looked at the law of sines. In 8.3 we're going to look at the law of cosines. And the law of cosines says that for any triangle with sides A, B, and C and opposite angles alpha, beta, and gamma respectively, the following three equations are true. C squared equal A squared plus B squared minus 2AB cosine gamma, B squared equal A squared plus C squared minus 2AC cosine beta, A squared equal B squared plus C squared minus 2BC cosine alpha. All right, a proof of this isn't too bad, so I thought maybe a quick look at this proof here. Suppose that we have a triangle, and I've got the sides labeled there, and gamma is an acute angle in this picture. The same proof is going to follow if gamma is an obtuse angle. I've got that indicated. And I'm just going to have us prove the first equation here. A similar argument would be if you wanted to show the other two. It's just really just kind of a relabeling of the sides and the angle that you're going to focus on. So we're going to be proving the first equation there. All right. Suppose that we go B units away from the origin, and we'll plot a point, and I'll call that point A. Point A is going to have coordinates B0. Point B is going to have coordinates A cosine gamma, A sine gamma. Okay, here's the angle gamma. I've got side A labeled in this triangle. Now, where's this coming from? Well, if I go to point B, I'll need to go x units to the right and y units up. So cosine gamma, if I were to observe a right triangle here, would be adjacent over hypotenuse. The adjacent side would be x. The hypotenuse would be a. And so x over a would be equal to cosine gamma. If you multiply both sides by a, that's where that x coordinate is coming from. Sine of gamma would be opposite over hypotenuse. The opposite side would be y units. Sine gamma equal y over a. Multiply both sides by a, and that's where the y coordinate is coming from. Okay. Now, in this picture, if we look at side C and calculate the distance between points A and B using the distance formula, then I've already got that set up. We want the square root of the difference in the x's squared plus the difference in the y's squared. I'll square both sides to get rid of the radical. And also I'm going to FOIL out these two parts underneath. B minus A cosine gamma times another B minus A cosine gamma would be B squared minus 2AB cosine gamma plus A squared cosine squared gamma. Over here you're squaring a negative, so it's going to be A squared times sine squared gamma. If you factor out an A squared, that's going to leave you with cosine squared gamma plus sine squared gamma, which is 1, right? That's one of our Pythagorean identities. And, okay, you can move this term right in front or not, but that's, at that point, you're pretty much, you're done. Here's what I've circled. That's that first equation that I was wanting to prove is true. Okay, now you want to be using the law of cosines in a situation where you're solving a triangle and the line of the law of sines won't work. Okay, because in the law of sines we have to know an angle and its opposite. Okay, if we have a triangle where an angle and its opposite are not known, if one of those is not known for every angle or side, the law of cosines is our only option. Okay, otherwise, if we have an angle and its opposite known, we can use the law of sines. Now, in this picture, suppose I want to solve this triangle. 2 is opposite alpha, I don't know alpha. Okay, 5 is opposite beta, I don't know beta. C is opposite 20 degrees, I don't know C. So I can't use the law of sines. Okay, if I were to set that up, I would have 2 unknowns and not 1 unknown. All right, which means that my only option in this problem would be to use the law of cosines. Now, in the law of cosines, you may notice kind of like a Pythagorean theorem type thing going on here at the beginning, or at least I see that, A squared equal B squared plus C squared. One way that I remember the formula is that you're going to start with the, kind of something that resembles a Pythagorean theorem, and then you're going to subtract 2 times the product of the two sides that you're squaring here, the two numbers that you're squaring, times cosine of the angle that would be opposite the side that is on the left. Okay. So if I want to find C first, okay, gamma is opposite C, that's 20 degrees here, and I'll be using this formula that I've got circled. A would be 2, B would be 5, and I've plugged in the numbers there. 4 plus 25 is 29, and then it's going to be minus 20 times cosine of 20 degrees. I want to find C, so take the square root of both sides. Of course, you can disregard the plus or minus here since we're talking about distance. That can't be a negative. And then go to the calculator. And like all these other problems, make sure that you're in degree measure for what we're doing. And we want the square root of 29 minus 20 times cosine of 20 degrees. Okay, and I'm getting 3.19 roughly if we go nearest 2 digits on that, and that's what I got there. Now at this point, I could use the law of sines since I know C and C is opposite 20 degrees here, or you could just stick with the law of cosines again. Okay, we still have to get alpha and beta. If we get one of those angles, we can get the other by knowing that the sum of all 3 angles in any triangle is 180 degrees. So I'm going to get angle alpha next. Now here's the law of cosines again, but for when we're working with angle alpha. And A is 2, B is 5, C we just found is roughly 3.19, and so I filled in those numbers. And I'm getting cosine alpha all alone, and then going to take cosine inverse of both sides. Negative over negative is positive. So if we do that, grab my calculator here, cosine inverse of 31.1761 divided by 31.9 is 12.2 roughly if you go nearest 1 digit. Okay, and so I've got one angle is 20 degrees, another angle is 12.2 degrees. The third angle would be 147.8 degrees, since if you add all 3 of these angles together, you get 180 degrees then. All right, so at that point, we would then have solved the triangle. Here's another example. Okay, solve the triangle. And now in this picture, I've got all 3 sides known, but all 3 angles are unknown, which means that the law of sines is not going to work, right? I need to know an angle and its opposite side. I don't know any one of those, no matter what angle I select. Okay, so my only option is to start the problem by using the law of cosines. We'll get alpha and then beta, and then once we got those 2, we can then get gamma at the end here. So here's my law of cosines, and I have solved this equation for cosine alpha. Okay, if I add 2bc cosine alpha to both sides and then subtract a squared from both sides and then divide by 2bc, then this is going to be, the same formula, just it's been solved for cosine alpha. A is 8, B is 5, and C is 4. So I plugged in those numbers there on the right and simplified. And then you can take cosine inverse of both sides to get alpha to be roughly 125.1 degrees. To get beta, we can use the law of cosines again, okay, but the one for angle beta here. And so I've got that equation written there again, the law of cosines, and then I've solved for cosine beta. Again, A is 8, B is 5, and C is 4. So I've plugged in the numbers there into the appropriate spots on the right, and then simplified, and then take cosine inverse of both sides, and I'm getting beta to be roughly 30.8 degrees. If alpha is 125.1 degrees and beta is 30.8 degrees, then gamma would be 24.1 degrees, since if you add all three of these angles, you'd get 180 degrees. Okay. Of course, again, once in a problem like this, like if I had found alpha, I could have used the law of sines, at that point, since 8 and alpha would be known. Either way. All right, I just had one more problem that was a problem in the book here on page 550. Problem 44 is an application problem. We'll take a look at that. It says that an airplane flies due north from Fort Myers to Sarasota, which is a distance of 150 miles, and then turns through an angle of 50 degrees and then flies to Orlando, which is a distance of 100 miles. So they give us a picture there. This plane's going to start at Fort Myers, fly 150 miles north, and then turn through a 50-degree angle and then fly 100 miles to Orlando. Okay, now I have redrawn that picture and included the labels there. Of course, if the plane were to fly, continued flying north, it's taken a turn of 50 degrees, which means that if I were to just look at the direct shot from Fort Myers to Orlando and call that distance of A miles, I'm going to have to find that in part A here, then I've created this triangle where the angle that would be opposite side A would be 130 degrees. Okay, since a straight angle is going to measure 180 degrees, 180 minus 50 would give me 130 degrees inside of this triangle. Now in part A, for this problem, it says how far is it directly from Fort Myers to Orlando? Okay, well that's what we're calling A miles in this triangle. This would be another law of cosine situation, right? Since A is opposite 130 degrees, I don't know A. This angle here, I could call that beta, although we're not going to use it. Beta is not known. 150 would be opposite beta, and then 100 would be opposite gamma. Okay, so I don't have an angle and its opposite known in this problem, which means that the law of cosines is my only option in order to begin. I need to know A. A squared equal B squared plus C squared minus 2BC cosine alpha. Alpha would be 130 degrees. B is 150 and C is 100. So I've plugged in those numbers into the appropriate spots, and